So just to, in the interest of time, I'll get started. So if you don't know me, my name is Gloria. I am a postdoc at NORLab, and I am a part of the community science team, and I'll be hosting today's assembly along with Greg Medeshki. Um, so the agenda for today, we'll start with a few announcements, and then I'll do a short presentation on AGN and the early science program. And then we'll switch over to Greg, who will show us how to use the portal, and then I will show you a notebook, and then hopefully we'll have some time for questions at the end. Um, so if you're new here, welcome. And so in order to participate, to actually like follow along with the tutorials, you need to have a Rubin Science platform. But so if you haven't gotten one, or if it hasn't been approved, you can still just watch and follow along, and then maybe like catch up with the notebooks later. So a few announcements. We have the Rubin Community Workshop coming up here in Tucson in a few months. So highly encourage you to sign up if you didn't already. We are currently having a special series for the science seminars. We have the active galactic nuclei one today, and next week we'll have the solar system. There's an upcoming users committee meeting on April 28th, and I'll say a little bit about what the users committee is. And also, we have a call for input from the community to create some community filters for Antares. So if you're interested in creating some filters to get some alerts, that is due on May 30th, and you can check out the community forum post. Now, I mentioned the users committee. So this is a committee that solicits feedback from the community of users, such as yourself, and can recommend any improvements based on that feedback. And like I said, so these are all the people who are in the committee. So if you have something that you want to communicate, please join on April 28th. We are still in construction, but the LSSC science camera has been installed, and there's been a lot of things happening recently, like the things that are in here. But yeah, very exciting times. So link frameworks is meant to enable scientists to actually take advantage of all of the data that the LSST will produce, focus on software, and they have some office hours on Thursdays. So if you would like to get some help from them, you can join. Once again, the Rubin Community Workshop is coming up in the next few months. But yeah, and hopefully we'll see you next week as well. So this science seminar is focused on active galactic nuclei. So here's just some background on AGN. You know, we know that there are suppressed black holes at the centers of massive galaxies, and some of them are actively accreting supermassive black holes. This is just a little drawing of like the anatomy of AGN. There's a supermassive black hole. There's some gas rapidly orbiting. We call this the broadline region. They may have a jet, but one thing to note is that active electric nuclei are intrinsically multi-wavelength objects, so they emit at every wavelength, and so you can, by studying in any specific wavelength, you can learn something new about it. And this is just some cool pictures of jets. And all these slides were created by the community science team, and especially some of these by Greg. We know, thanks to the Event Horizon Telescope, we know for sure that this is what AGN looks like. We don't always get such cool pictures of AGN. Usually, we can study them based on their spectra, and you see that different types of AGN have different types of emission. But yeah. Another way to study AGN is using photometry, and usually if you observe an AGN in photometry, you'll see that they're variable objects, and they are variable in every wavelength. And this is just showing multiband light curves for two different types of AGN, a radio quiet one. You'll see it's pretty variable, but another one that is jet dominated, a radio loud AGN is even can be more variable. And it's just a cool picture because AGN people don't get enough cool pictures. But so this is just an image from the science assembly that Melissa did a few weeks ago, showing some gravitational lensing that also involves variability. But so we are here to talk about the legacy survey of space and time. And so the LSST can contribute to AGN studies due to its large volume and also the fast cadence in multiple bands. So this is just showing sort of like some the expected visits for different areas. But you'll see that, so this area here is the Wide Fast Deep survey. And there will be some areas like the deep drilling fields that have a higher cadence, which will be super useful for AGN studies. But so all of this is still like being determined. So if you're interested in like what the current plans, current recommendations for the cadence and stuff, you can check out this this note here. So one thing that will be cool about the LSSC is that we will have the largest number of AGN. So I think current surveys, you know, are in the order of like hundreds of thousands. And with the LSD, we might get like 10 million. So this is just showing sort of like some expected numbers for high redshift AGN. So like greater than 6. And that could be possible thanks to the inclusion of the Y band. So thanks to Greg for sharing the slides. So AGN can be selected by various methods. This is definitely not all of them, but they can be selected by their colors. Like I said, they're variable sources, so they have specific variability signatures, so they can so that can be used to identify them. And also, if you so you know, we have like the LST will have synergies with other observatories that can be used to detect AGN in different bands, and then you can then look for them in the LST data. So some of the things that you can look forward to. So you might have heard of vibration mapping, where you observe an AGN over time in both photometry and spectroscopy to measure time lags between emission in the broadline region and the accretion disk to measure masses. Maybe so there are with the LSST we will not have spectroscopy, but we will have hopefully some high cadence enough that we can actually measure time lags in between different the different emission in the disk itself. So this is just an example showing different bands observations of the accretion disk, and if you do some analysis, you can see that there's actually some time lags between the different bands, and that can tell you sort of like accretion disk sizes. So it's super useful to study the structure of accretion disk. And you can also expect to, because of its large volume, you might be able to detect some rare events like anomalous variability. So that is of interest. Another thing is so trying to measure periods and like trying to detect binary black holes. So if you are not already in a science collaboration and you're interested in working with other people on some AGN science, there's the LSST AGN science collaboration. Here they have several subgroups dedicated to AGN selection and classification, measuring photometric redshift. So this will be especially important like for AGN, and so variability science, and then following up any sort of like interesting AGN that you might find. So the co-chairs are Neil Brandt and Matthew Temple, and you can go to this website if you're interested in learning how to join. So we are so Rubin has an early science program, and part of that is the data previews. Right now, we are in data preview 0, which is based on simulated data, which is what we'll be using today. Then we very soon we have the data preview 1 based on the commissioning camera, which was on Sky late last year. And then we are working towards having observations from the LSC science camera, which based on the first few months, we'll have the data preview 2. But if you're interested in learning more specific things about the early science program, or like if you just need something, like to reference for like your proposals, you can check out the Rubin Tech Note 11, which will have all of the details for you. So this is just a timeline of what's coming up. So we are sort of like working towards this, where we have the first photon from the LST camera. Then what we will have a system first light or first look event. And after that, we will have the data preview 1, which will contain data, like I said, from the commissioning camera. But yeah, and then we'll have the data preview 2. So some of the data products that might be useful for AGN science. So we'll have the LSST will provide some images that includes single visit images, so sometimes called a CalExp. And then from those single visit images, we'll create co-added images, which are divided into tracks and patches, and they will be referred to as deep coads. And then there are also difference images, which can be useful to see if sources are variable. There are single visit images that have had templates abstracted from it. Now, from all of those images, we'll also have some catalogs, and I'm showing essentially most of the catalogs here. On the left are the catalogs produced from the direct images, and on the right from the difference images. So there will be a source catalog which contain 5 segment detections in a single visit image, and then there will be the object catalogs, which are the ones that are detected in coads. So if anything was detected in the object catalog that wasn't already in the source catalog, the pipelines will also do force photometry at the location of those objects. And then so for the difference image analysis, there will be a DIA object catalog which contains summary parameters for light curves, and then similarly there will be a force source catalog, and this is on direct images, not difference images. So something that might also be of interest is the LSST prompt data products, which include the alerts, like I said. So this could be something like if there's like a super an anomalous AGN event, you might want to get an alert about that. But yeah. So some of the data products that will be available in the DP1 are the process visits images and source catalog, the co-added images, and then there's a stretch goal to include some time domain catalogs like the force source and the difference images. Has it ever decided how DC are? I do not know the answer to that. Do you know, Greg?
No, I don't know either. I think that's something that we need to look up, and we'll certainly let you know, Gordon, what is this, the current status of that.
So the ComCap observations included 7 fields, and I just wanted to point out that the extended Chandra field south is the field that was most observed, as you can see from this, and it was observed for 21 nights, 21 out of 33 nights. So what this tells us is that there should be at least some time domain science that is available with the DP1. So after this, okay. So as many of you know, there are no AGN in the data preview, unfortunately, but we can still explore all of the LSST data products that will be available in the future that will contain AGN. So we'll be using variable stars mostly to explore the data products. We'll start with a portal tutorial that Greg will lead, extracting light curves and also examine images. And then I'll do a notebook tutorial that will cover many, many things. So for the portal tutorial, you can follow along on using this link, but Greg will also just show you how to get to it. And then we will need to do some, we'll need to use Git to actually to get the notebook later, but I'll cover that when time comes. So Greg, if you want to share.
Okay, Gloria, thank you very much. I will start sharing my screen as well. Hi, I'm Greg Madejski, and again, I do work on AGN. That's one of my main research areas. And what we will actually try to cover here is a little portal tutorial about how to extract a light curve of a variable object. As Gloria mentioned, AGN are luminous point sources. They are in centers of many galaxies, and very often they're brighter than the host. And they're characterized by distinct spectrum, but also very often reveal variability. And as Gloria mentioned, the ones that are also detected in radio and often gamma rays are very often variable at very large amplitudes. So the studies of variability can actually not only tell us about the accretion disk, but also can give us some hints about what is the nature of the jet, and maybe, hopefully, we'll be able to tell why is it that some objects are radio quiet and others are radio loud and contain those relativistic jets. So this is a graphic demonstrating just various types of active galaxies. Again, in data previous 0.2, which is what we're using here, there are no AGN. We are almost certain that there will be AGN in some of the ComCom data, and we know that independently of Rubin, simply because those are fields that have been explored very extensively in many different wavelengths. So definitely please do watch this space. Okay, so at this point, let me just get started on this tutorial to look at the variability of a source. We know of one source that is for sure variable. It's an Arrow-Lyrae star. Again, this is just a simulation, and has coordinates of the value that is listed on the screen here. So if you already are connected, and if you have the if you're in a Rubin Science platform, you can probably just go into the portal. So let me now switch screens. And again, I will just move this one off to the side. And here will be my other screen, which will be the Rubin Science platform. Okay, so you will want to log into portal. So click on that. And again, presumably you're already logged in, so you will be able to see this image. What we're going to go to is the DP 0.2 catalogs, which is what we're going to be extracting the information about that particular star. What I want to do here is, first of all, because of the fact there might be multiple objects, or maybe there might be some issue with confusion, instead of just giving ARIA deck to the whole search, what we're going to do is, first of all, we will find out what is the DIA object value, what is the particular value of that. So this is, we're going to go into catalogs DIA object, and again, we'll try to find out what would be the DIA object ID. This is basically what we're after. And again, another thing I'm going to click, you can go ahead and follow me, is the number of observations of this particular source that of all the sources that would be coming up in the in our search. Again, I already have my my ARIA deck clicked into this box. So again, you might need to only consider just the spatial coordinates, and for the radius, I think I would just put 3 arcseconds here. Okay, if you now click on search, you'll quickly discover that there are 2 objects which have more than one observation, and obviously the DIA object ID that you want is the one that is on the bottom left, which is the number that you probably already have in your in a tutorial. So this is just to illustrate how to make sure that you have data only for this particular object. All right, so now at this point, we're going to work with the Rubin Science platform, and we're going to execute the ADQL query, which will bring out the fluxes for that particular object. But what we need to do is we need to make sure that we also have the time of the observation. So this will require joining multiple tables. So those of you who are familiar with the ADQL will probably see that that makes perfect sense what's going on here. But what I'm doing is I'm basically selecting the exposure from this table called CCD visit. That again is the first one of those that I select here. And from my force source on DA object table, I am extracting flags error, and importantly, also the band of the observation, simply because of the fact that I initially will want to have the light curve in all bands, but then I will select just one of them. Okay, so let's move forward and let's pick up this particular ADQL query, and let's move it into the portal. And again, I'm going to go back and do DP0.2 catalogs. And now I'm going to, since I am working with the ADQL, I'm going to click on that. And here in the ADQL box, I'm entering the values or the information that I had in my tutorial. And then after that, I'm going to simply click search. I'm assuming that you all can see it. And if there's any problem, please let me know. Okay, very good. So you can see that we now found a light curve of this object. And again, on the right-hand side, on the left-hand side is basically something that that is not relevant here. So it's just the right-hand side panel here that has light curve of this particular star. Again, presumably you would be more interested in AGN. So if you gave the array and deck of the AGN of interest, you would get the DIA object ID, and you would have that now plot as a flags. Okay, so moving along with the tutorial. So let me just go back to this screen, and you can see that in this particular query, I am going to have multi-band light curve. Again, the display in a tutorial looks a little different than my own display, simply because of the fact that there is a way to reconfigure those displays. By the way, the reconfiguration of the displays, if you want to learn more about it, you can probably look at some of the how-to tutorials that we prepared. But here we can have you can set up a different layout depending on what you choose. Okay, so in order to be able to pick up just one specific band, you, for instance, want to only observe or you want to study the light curve in the band I, you just click on the little down arrow here, then you put a check mark in the letter I, and you click on apply. And notice that magically, all of a sudden, in the I band, the light curve has, of course, a lot more sparse. And again, you can create this image to be a bit more pretty. You can just put into the X not only the MJD, but MJD minus 60,000, and that will give you a bit better sense of how many days there are for this particular observation. Okay, you can apply this, and again, you can close this, and now you can see that you have the light curve spanning of about 1,600 days. So this is a length of the observation of this particular field. All right, so this is basically a sense of how to get this single filter light curve. Another thing that I wanted to show is how to extract an image for the place for a specific location. And the way you would do that is you would go back to the Rubin Science platform. You would go into DP0.2 images, and then from those images you can pick up for instance, some very specific location. So in the query type, you can just put this particular number, and that will return the images for this particular location. So let me just quickly just put it here. Observation would be containing this location. And for the time being, we're not going to be bothering with the timing or spectral coverage or anything like this, just for simplicity. I want to make sure that I leave plenty of time for Gloria to continue with her notebook. So if you click search on this particular one, you'll get a number of images that would be available. Notice that this is on the left-hand side, you will see all the images that have been extracted. So there'll be a large number of them, you can actually see that there'll be more data products than just one image. But this will give you all the data that the system is a little bit on a slow side, so that's the reason why it takes a couple of minutes. But this will give you all the images that might contain the location of your AGN. If you, for instance, would like to study the host galaxy of the AGN. So at this point, I want to make sure that as I mentioned, I give plenty of time to Gloria. You can play around and basically extract maybe only images that are extracted during the specific range of times. You can set timing. You can also set the spectral coverage. And again, this is something that just illustrates the flexibility of the portal. So I think at this point, I will stop. I think I'm already probably a bit more than I should have allowed for this. So if maybe this is a good time to stop and ask if there are any questions. So let me maybe stop sharing the screen and see if there is any questions. So please raise your hand if you would like to have me elaborate on anything. But I don't see any hands raised up. So Gloria, it's gonna be your turn now.
Thanks, Greg. So I'm going to be using the notebook aspect. Oh, let me put something in the chat, actually. No.
So let me maybe just say one thing that I forgot to mention. I think that the idea is that if you are a novice, if you want to just get started with Rubin data, you probably start with Portal and then learn about the content of the data and so on and so forth. And if you decide that you want to go into a little bit more detail, if you want to do some kind of analysis, which will require running Python code, then you want to go into the notebooks aspect. So that's sort of the duality of the Portal versus notebook. So I just wanted to add that.
Yeah, thank you. I just wanted to put the in case you don't have the slides open, what you'll need to actually get the notebook. So if you go to the Rubin Science Platform at data.lc.cloud, so you already use the portal. So if you go to the notebook, I haven't started it yet, so it's because I wanted to show you what it will look like. So if you are signing in for the first time in a while, you'll get this, and so the pipelines change quite often. So you'll have to select which version of the pipelines you want to use. So we have a recommended version, which is weekly 2025 09, and you'll have to select a size for your server, essentially. So I think we said recommended medium, but you can also use a large. So then you would just start, and if this is your first time, it will probably take a bit, but okay, cool. Hopefully no one had any issues. So this is, if you haven't been used the notebook aspect before, this is what it'll look like. You will have a bunch of directories. There's also a bunch of tutorials here that you can just access that, and this is updated constantly. So to actually get access to the materials for today, you can, let me start from here. You can click here, and that will lead you to a launcher, and you'll need to go to the terminal, and you can just paste what I put in the chat or in what is on in the slides, and that should get all of the materials that were prepared for this science seminar series, including the one for today. So if you did that, you then see on the side, you will see now DP1 science prep seminars, and you can just click on that, go to active galactic nuclei, and then just open the just click on the notebook, and that's what we'll be using for today, and we'll see how far we get with this. But so again, we do not have AGN. So anything that is included in this notebook is likely a variable star. But so we typically, and so what I'll cover in this notebook is showing how to access light curve data for probably the same star that Greg just showed, based on AGN deck, do a little analysis, and then I'll show how to access the light curve summary statistics, which may be useful for identifying AGN variability. And then lastly, if we get to it, I'll do some color diagrams and then get a light curve for a specific object. But so typically, we start by importing packages. This includes some common packages like NumPy, Matplotlib, AstroPy, and I also am using some SciPy for statistics. And then lastly, the LSST specific packages like lsst.rsp, which gives you the tap service, which is what we'll use to actually get the data. So, and if you haven't used Jupyter Notebooks, you just click Shift Enter in order to execute the cell. Now we also include some parameters for your plots so that all of your plots are consistent, and we just define some colors and symbols for all the different filters. Now I have we typically also start with defining some functions. I have defined this function to calculate a periodogram, which was totally unnecessary, but why not? And this uses the Lomscargle function from AstroPy. And then we'll be calculating some structure functions. And for this, I am using code from that was presented by Kovacevic et al. In 2021, and it's from this GitHub repo here. So after you're defining your functions, we typically start with the initializing the tap service. So you just put get tap service and tap. Now, the first thing that I'll do is create a light curve from force photometry from the force source table. Can I increase the font? Does that help? Yeah, okay, cool. Where was I? Okay, so we'll be using the force source table. So I believe what Greg just showed you uses the force source on the IA table, so it's different. But we know that there's our Lyra star at this location. This could be like the first thing that you do, you have your favorite AGN, you define the coordinates, and then you get its light curve. But we'll just use this star for now. Now, so some definitions, again, the force source table provides force photometry on the single visit images for things that were detected in the object table. So because of that, everything in the force source table can be identified with an object ID. And also, you should know that all of the time information is actually not included in that. It is in the CCD visit table. So we'll do some table joins. So the first thing that we want to do is to find the object ID for this location. So I'm just creating a ADQL query here for a very small area around that RAN deck. And another useful thing is you want to use detect is primary equals 1, so at least for now, so that you get only the blended sources. But so that I just created a query, and then because in the future you might have some very long queries, some queries that take a long time, you don't want to necessarily be stuck waiting for that. So this way of running the query just sort of like puts in the background so you can continue executing your notebook. So we'll be doing this throughout the notebook. So you just like submit the job, and that should tell you if there was some error, and hopefully you'll see the word completed. That means that your query is done. And then once your query is done, you can fetch the results, and typically we save these in an AstroPy table. But you'll see here that the query returned exactly one object, and you can see its object ID, which is what we want. Now, once you have that object ID, you can use that to find all of the core source measurements for that. And we do not provide magnitudes directly, but we do provide this useful function that can calculate magnitudes for you. But this is just getting a flux and some time information from the visit table, or specifically all of this sources matching that object ID. And then I'm just running a query. Now you'll see that there's a bunch of sources in the for source catalog, and for this result, they all have the same object ID. Now, so what we want to do is actually plot the light curve in multiple bands. As if you see here, this query returned the light curve information for a bunch of different bands. So this will just be helpful in the plotting so that we can plot them individually. But this is just some normal plotting. But you'll see here the light curve from this object in UGRIZY, and you will see that indeed this is a variable object. So one thing that you might be interested in doing with this is investigating some variability timescales. So this is a variable star that follows a period for the variability. So the first thing that we'll try to do is to extract a period for this variability. And I'm just here saving saving the light curve information into like MJD and magnitude, and then sorting by date just to be super safe. And then in this cell, I'm just calculating the long scatter periodogram, looking for periods between 0.05 to 1.05 days, since that should include the type of period that an RR Lyrae star has. And then I'm just trying to find the best period from that, and I'll just show that looks like in both, like in the periodogram, both in frequency space and period. But okay, and I'll try to go a little faster. And then, so for AGN studies, something that is commonly used is the structure function that can tell you sort of like how the the variable source changes at different time scales. So this is a variable star, so it's not gonna not gonna look like much, but I just wanted to include it, and then also provide an example of what this might look like if you had an AGN. So I've generated a fake light curve for AGN using generate damp random walk, which describes the sort of variability that AGN has using the package AstroML. And since that is not typically included in the science platform already, I've done that separately and just included some files that you can just read in. And after reading it, so for this, I'm including a light curve that spans the entire the observing range for the star, and then I've selected only the points that match the actual observation dates for the star, in order to sort of like simulate sort of like what the cadence of the AGN would be. And a note on cadence: the DP02 data does not have the most recent cadence plans, and also it does not have deep drilling fields, but so it won't exactly match the future, but is still a hopefully useful exercise. But now we're calculating the structure function. And then I'm just going to plot that so you can see sort of like what you might expect if this had been an AGN. So this is a light curve showing again a full light curve for the entire period of observation, and then just for the specific observing dates. And here I'm showing the structure function for the full light curve as a line. As you see, eventually at longer timescales, it sort of like flattens out. And the point that I was trying to make here is, so for when you have not the full light curve, but only like the specific cadence, you'll see that you get a different measurement of the structure function. So, but yeah. Another thing that, like I mentioned, that you might want to do is try to find a specific variability, like curves that follow specific variability. So the DIA object table has light curve statistics. This is the ones that are currently there, including minimum and maximum flux, and this is from difference imaging. It has various ways to describe the scatter around the mean. It shows you sort of like how many data points there were in the light curve, and also includes like something like this Stetson J parameter might be useful for like to find variable stars. So that might be of use if you want to explore this data further. But the important part is that this is still like being determined. So if you go to this tech note, you can see all the different things that are being explored to be included in the future. But yeah. So here I am just going to define some coordinates again. Here, this is the center of the simulated data. And first, just to start small, I'm just doing a little query for just looking at the number of data points essentially per band. And I'm just going to go through this a bit quicker. And this just shows you like for things that have a lot of detections in the DA sources, see how that changes depending on what the actual number of data points. It depends on the filters, where the RNI band have the most data points, and the G band still has a lot, but then for U, Z, and Y, that may be a bit different. But so that was sort of the start. Now you'll see this very, very big query. So I'll start by defining some selection criteria. These are like super basic. So I encourage you to set your own and explore what you get. But I've just defined here a minimum number of DA sources per DA object, some magnitude ranges, and then some amplitude. And then here, I'm just grabbing a bunch of the statistics, the number of data points. I am defining a amplitude in the R band, and then I am also grabbing light curves since after the query, I want to actually see what the objects look like. But so here, all I'm doing is plotting light curves of the first 20 objects. And you'll see here that my query returned only 43 objects. But so these are well sampled and have an amplitude of around 0.5 to 1 to 2 magnitudes. But yeah. So you might want to select one of these if it looks interesting to you for further exploration. And then lastly, another way that you might go about selecting some AGN or some variable stars here is through color diagrams. And I also wanted to sort of like show you a little bit more about the object table, which so far has only been used to get the object ID. So for this query is for looking for point-like sources within 10 degrees of the center coordinates. And I am just grabbing the magnitude and all of the filters, and also defining that I only want point-like sources. So for that, we have this extendedness parameter, which is 0 for point-like sources and 1 for extended objects like galaxies. And here I am just calculating some colors in all of the bands. And then I'm just going to plot the color diagrams. So these are all likely stars. So so for AGN, which are point-like sources like stars, you would just find them sort of like outside of where this like the group of stars lies. So and that will look different in the different color diagrams. So for this one in particular, well, for all of them, they kind of lie, depending on the redshift, they'll lie in different parts of the color diagram. But I know there are many AGN that fall in this area. So for the purposes of having something to look at, and because we all get, you might have noticed that your actual color diagrams look differently. All I'm going to do is select the point that is at the bottom and to the left. And I'm just doing that here by finding the minimum of the sum of the two colors. And then I'm grabbing the object ID for that particular object. And here I will just display, I think oh, there it is. I see it here. I'm not sure where it is in the other ones. When I had it before, it was over here, but we'll see. Okay, so we have selected an object. And now we want to grab its light curve. So here we're using, again, the force source and CCD visit. And here. So your light curve might look different, but something here you could, depending on what you got, it might be super obvious if it's a variable object or if it isn't. And if it's a variable object, you could do some further exploration, some analysis to see if this variability is similar to that of an AGN. But that is the end of the notebook. And now we have some time for questions. And if there are no questions, I also welcome suggestions of what type of things you would like to see in future tutorials, since we haven't had too many like AGN specific things. So it would be useful to know what you want to see as we go forward to DP1.
Are you Gloria, are you going to be looking for AGNs in the ComCam data?
Yeah, many people. Yeah.
As I mentioned, some of the ComCam observations are for extended Chandra Deep Field South, and that's incredibly well studied in many different bands. And to the best of my knowledge, there is a number of AGN identified from previous surveys, from X-rays, from optical and spectroscopy surveys, and that. So we are very much looking forward to that. Needless to say, we have not really done extensive analysis of that, but we're getting ready to, when the data get released, to start showing it to the general public.
Okay, another question. So for AGNs, I mean, you're looking for colors and everything. Do you have to de-redshift them before you put your colors together?
I did not for this demonstration, but I would assume so. I have not personally done this before, but there are definitely many corrections that can be done that I did not include. Yes, Paolo.
Yeah, I was wondering, are there a library of pre-computed statistics besides the one that you showed? Like there's a FATS with CFA, fast timing statistics, is there going to be a library of pre-computed things? Like you search for the percentiles of variability, you had various metrics for getting how much variability amplitude is there,
Yeah.
but there are other things that you can compute. Are there other things that are going to be pre-computed? Who decides that?
Yeah, so okay. So I mentioned the tech note that I'm gonna put in the chat. So that sort of like includes some possibilities. So one avenue where you can sort of like communicate which ones you want to see would be like the users committee. I meant to say that. Thank you for asking.
And also, in addition to what Gloria just said, I think that there's a number of contributions coming from various teams from United States and also from outside of the United States, preparing a variety of tools to be able to analyze the variety of variability analysis for Rubin data. So that's very much work in progress.
There are another question. Greg, how many light curve points could an AGN have from ComCam data? Like, what do you, tens, 100? No.
Well, I think that it's essentially the same number of data points as the number of observations from Chandra Deep Field South, so from ComCam data. Gloria had shown this. I simply don't remember, but I think that was several months worth of pointings. I think that.
So this field had the most, and it was 21 nights, but there are multiple. It seems like
Multiple pointings in each
yeah.
night.
Yeah.
Right. So
Cool,
the
thanks.
idea here is not only to look for some kind of circular variability over a period of a month or so, but also look for variability of some of those objects on a very short time scale. As you probably know, each exposure is 30 seconds, so that means that's the time resolution that you have for the variability studies.
Wow.
And I guess I can stop recording.
Yeah, you can probably stop recording. I think at this point, if any of you want to go back to your